In our second unit, we began doing work to figure out how to solve equations. And remember, an equation is where we have two expressions that we're showing to be equal using an equal sign, like this. This is an equation. We have two expressions that are shown to be equal to each other. And when we solve an equation, we're looking for what does this variable equal to? What number goes in the place of that x to make this equation true? Or another way to say it in this example is, what number minus 5 is equal to 8? And we figured out how do we solve that type of equation. What skills can we use to do that? And our final answer, x equal to 13 in this case, is our solution. And that's what we call that final answer. And this is what we did to solve an equation. We have our equation here. We identify that it's a minus, x minus 5, and we have to do the opposite operation. But we have to do it to both sides to keep things balanced. And that's how I get x is equal to 13. Well, you can actually do the same thing, this type of solving procedure, for inequalities. Okay? Instead of an equal sign, we'll use the inequality symbols. And we can use the same skills that we do here in order to figure out what value goes in for the variable in that inequality. And that's what we'll look at today. Let's look at one solved example first before we get into some other examples. So here I have an inequality, x minus 2 is less than 5. Okay, that's an inequality because we have an inequality symbol there, that less than symbol. And so what this is saying is that some number minus 2 is less than 5. And so we want to figure out what number could possibly go in the place of that x. Now the thing that makes inequalities very different from equations is that the inequality can have a whole range of answers. An equation just had one, x equals 13. This one will have a whole bunch of answers, a whole bunch of possible numbers that could go into x or go in the place of x to make this inequality true. But to solve it, we can actually do the same thing that we do with equations. So I have x minus 2 is less than 5. I see that there's subtraction here. It's minus 2. And I want to remove that 2, get rid of it, so that the x is by itself on this left side here. And so how do I get rid of that minus 2? I do the opposite operation. I do addition. Okay, that's the opposite of subtraction. So I add 2. And then that 2's gone. That minus 2 plus 2 is 0, and so I'm left with just x. But I have to do it to both sides of the inequality, because I have to keep things balanced. So if I add 2 here, I also have to add 2 over here. And when I do 5 plus 2, that's 7. And so I have x is less than 7. And that's my solution. Okay, what this is saying is that any numbers that are less than 7 would make this inequality true. What's a number that's less than 7? 6. 6 minus 2 is 4. Is 4 less than 5? Yes. Okay, what's another number that's less than 7? 0. 0 minus 2 is less than 5. Is 0 minus 2 is negative 2. Is negative 2 less than 5? Yes. So you can see that any number that's less than 7 is going to make this inequality true. So that makes it a solution. Okay, so that's the difference with inequalities, is there a whole bunch of answers, and that's what we represent with our final answer. And then we go to the graph to show it more visually what we're talking about. Remember, this graph shows all the numbers that are less than 7. Okay, the arrow is pointing to all the numbers to the left of 7, and we have a circle at 7. And notice that it's an open circle because it doesn't say less than or equal to 7. It just says less than 7. So 7 is not concluded, or not included. Because if you think about it, if I put 7 in for x, 7 minus 2 is 5. Is 5 less than 5? No, 5 is equal to 5, so it's not less than 5. So we can't say that 7 is included as an answer here. Okay, so this is how we're going to approach these problems. We're going to solve the inequality, and then we're going to graph our solution. So let's look at some notes for solving inequalities by addition. First, we have this addition property of inequality. Okay, that's just a definition that says adding the same number to each side of an inequality. So if we add the same number to both sides of an inequality, remember we're talking about sides, we're talking about on the left of the inequality symbol and on the right of the inequality symbol, that produces an equivalent inequality, which is kind of a funny phrase because inequality is about not being equal, equivalent means equal. And so what this is saying is that if I add the same thing to both sides of the inequality, it's still an inequality in the same sort. Okay, it's not going to change. The numbers may change, but it's not changing what it's actually saying. Let's look at some examples. A down here. Remember, we're going to solve the inequality and then we're going to graph our solution. So we have x minus 6 is greater than or equal to 10. So we're looking for what is x, what is x greater than or equal to in this case. And so we want to get rid of that minus 6, and so we do the opposite. We'll add 6 to both sides. Well, minus 6 or negative 6 plus 6 is 0. So that leaves us with x. We bring our greater than or equal to symbol down, and 10 plus 6 is 16. So x is greater than or equal to 16. And that's our solution, and so we're going to graph our solution onto this number line. And again, it doesn't have numbers, so you'll put the numbers where you want them to go. And you can kind of put 16 anywhere you want onto here. You just want to make sure that you leave room to draw the arrow for stuff that is greater than 16. So I'm just going to put 16 right here, just a little smaller. And then I'll do numbers that are smaller than that, and numbers that are larger than that. And so my solution is x greater than or equal to 16. And so I'm going to do a closed circle at 16 because it's greater than or equal to. And then all the numbers, draw my arrow to the right, because all the numbers that are bigger than 16. Okay? Again, on yours, you can draw your line above the number line, or you can just shade it in really well, or if you have different colors. So that's how we're going to approach these. We're going to solve the inequality, figure out what x is greater than or less than, and then graph that solution onto the number line. Let's look at another example. B minus 2 is greater than negative 9. Okay, B minus 2 is greater than negative 9. So I'm looking for what B is. So if it's minus 2, I'm going to do the opposite. I'm going to add 2 to both sides. And B is greater than negative 7. And that's our solution. B is greater than negative 7. So you just do the opposite operation of what's there, and then you're going to graph that onto the number line. So I can put negative 7 right here, put numbers that are smaller than that to the left of it, and numbers that are bigger than it to the right. And I am wanting you to put those numbers on the number line because we want to make sure we know what numbers are smaller, what numbers are bigger. That's good practice for you to make sure you know the comparison between those numbers. So B is greater than negative 7, so I'm going to use an open circle in negative 7 because it's not equal to negative 7, but it's greater than, so that's all the numbers to the right. So that's what our graph would look like. B is greater than negative 7. So that's pretty much all of these examples are, is finding your solution, so adding, adding in this case, because we're just solving by addition, adding the same number to both sides, finding our solution, and then graphing it on the number line. C and D here, it says try it on your own, so why don't you go ahead and do that now, and then I'll just put up a slide with the answers for you to compare yourself. Okay, so go ahead and try C and D on your own. It's just the same as A and B, except C is going to be less than or equal to. So go ahead and try those on your own now. All right, here are the answers to C and D. You can see on C we just added 3 to both sides, and we find that m is less than or equal to 8. So all of the numbers that are less than or equal to 8 are our solutions here. And you can see the graph there with the closed dot on 8 and the arrow to the left. In D, we add 4 to both sides. We get S is greater than 3. Negative 1 plus 4 is 3. Make sure if you're struggling with negatives, you use your calculator. And so our solution is all the numbers that are greater than 3. So we have an open circle on 3 and an arrow off to the right.